Happy Wednesday, scholars. Today is Wednesday, April 22nd. So impressed with the huge improvements we saw in our scores yesterday, graphing points on a coordinate plane. We're going to start with some shout outs for 100%. Then we're going to move on. Today's lesson is going to get a little bit harder, to make sure you are prepared to write down all the questions along with me, do the math along with me, solve these problems along with me, and you will do great on your independent practice. But of course, for some shout outs for 100% yesterday. UNC, the most representatives. Huge shout outs to Jasmine, Ajane, Miguel Angel, Lyric, Tenby, Annalie, Dillery, and Latasia. Woo, nice work, UNC. Shout outs in SCU for Nevaeh, Adam, Zach, Amael, Corday, and Aiden. And then huge shout outs in Duke to Edwin, Larry, Eulity, Monica, Diana, and Tatiana. A lot of 100%, especially after not doing so well on Monday. Lots of these scholars came to office hours. They came to reteach. Not only are they earning Vista virtual points for that, but they're more importantly now much more successful with the math. Extra shout out to a lot of these scholars actually were scholars who had earned their free homework pass yesterday, so they didn't even have to do assignments, and yet still decided to complete the assignment anyway and even scored a 100%. So just so impressed all around with yesterday's work and excited for it to get just a little bit more challenging today. So yesterday and Monday, we were very focused on plotting points on our coordinate planes. We spent a lot of time talking about the x coordinate and the y coordinate. We talked about how we always go over first and then up when we're plotting our points. And so we are now really strong at what this coordinate plane means. We know the x-axis goes horizontally, the y-axis goes up and down, and when we want to plot a point or find a point, we go over and then up. We go over and then up. We go over and then up. And so if I wanted to find the coordinates, for example, for B, I would go over to 7, up to 4, and there I have my point B, 7, 4. This anchor chart is still available, so if you need to refer to it, it's a great resource, but today things are going to get a little bit trickier. Now that we are really strong at finding those coordinate points, now we're actually going to apply that and talk about, well, when would someone use this in real life? So let's actually take a look at a couple examples. When we're plotting coordinate points on our coordinate plane, another word for this could be a graph or a chart. So today we're going to be looking at some examples where it's not just like points A, B, C that have been plotted on there, but it's points that actually mean something. And how do we figure out what these points actually mean? Well, we do that by paying really close attention to all of the information given in our coordinate plane. So I'm going to start by reading my directions. This graph shows the outfits worn by contestants in this year's spelling bee. So I can see all of these points on my graph or on my coordinate plane, but instead of just being point A, point B, point C with no meaning, now each of them means something. I always want to start by looking at the title. The title will give me some extra information about what this graph is about. Attire, I know that's just a fancy word for clothes. So clothes worn by spelling bee contestants. And I know contestants are just people entering the spelling bee. So this chart is showing me what are these different outfits that were worn by all the kids in the spelling bee. The next thing I always want to look at is I want to look at, well, what is actually being shown on my x-axis and what is actually being shown on my y-axis. Just like we had before, we have our x-axis going across and our y-axis going up and down with points plotted on the x and y axis. So This label down here tells me that on the x-axis, this is showing the different outfits. What did all of these kids wear? I can see some kids wore shorts, some kids wore jeans, some kids wore skirts, some kids wore dresses, and then some kids wore other. I don't know, maybe that was a tuxedo or a swimsuit. I don't really know what that is, but they wore something else that's not on here. Then along our y-axis, going up and down, we have the number of contestants, which is just a fancy word for people entering the spelling bee. So this is telling me how many kids wore each of these outfits. So even before I read the question that's being asked, I already know quite a bit of information about this graph. I know it's showing me what did all the kids wear to the spelling bee. I can look at the different outfits the kids wore, and then I can tell, well, how many kids wore each of those outfits. Just for practice, let's take a look at shorts. How many kids wore shorts in the spelling bee? Well, just like I would do if I was plotting a point on my coordinate plane, I'm going to first go over to shorts and then go up to see how many kids wore shorts. And as I go over and then up, I see that 2 kids wore shorts to the spelling bee. Now I'm wondering, well, how many kids wore jeans to the spelling bee? So I'm going to go over on my x-axis to the jeans and then up until I get to the point right there. And I see that 8 kids wore jeans to the spelling bee. So they must have been just thinking about being really comfortable. Maybe it was a little bit chilly in there, not too worried about dressing up, just wanted to be nice and comfy for their spelling bee. That makes sense. Well, how many kids wore a dress? I'm going to go over on my x-axis until I find the dresses and then up. And 5 kids wore a dress to the spelling bee. I can tell that 4 kids wore something else. So I'm very curious. I'm picturing kids who dressed up in like a really nice tuxedo for the spelling bee. I don't really know what this other is, but there were 4 kids that wore something else. So I can use this coordinate plane just like we were yesterday to go over and then up. But now my points just have a little bit more meaning. But let's take a look at what this question is actually asking. This question is asking, what is the total number of contestants, that's just kids, who competed in the spelling bee? Interesting. So it's not asking how many kids wore shorts or how many kids wore a dress. It wants to know how many kids entered all together. So how am I going to figure this out? Well, I know that 2 kids wore shorts. I know that 8 kids wore jeans. I know that 7 kids wore a skirt. I can see that 5 kids wore a dress. And 4 kids wore that mysterious other outfit. If we had 2 kids in shorts, 8 kids in jeans, 7 kids in skirts, 5 kids in dresses, and 4 kids in other, if I add all of these up, that will tell me how many total kids were in the spelling bee. All right, go ahead and add these up on your paper. I'm going to add them up as well. We'll see if we get to the same thing. I'm going to start with number combinations I know right off the top of my head. All right, and I look at my multiple choice choices and I see that D is in fact a choice. So I was able to figure out the total number of kids who competed in the spelling bee by finding out how many kids wore each different kind of outfit. I knew this showing the total number of kids in the spelling bee. Just like with my coordinate planes, I went over to find the outfit and then up to find the amount of kids that wore each outfit. All right, let's take a look at another one. Let's now take a look at question 13. I want to make sure I'm paying very close attention to all the information given. So the graph shows the number of drummers in the school band each year over a 6-year period. Lots of times, charts like this or coordinate planes like this, they're going to show something that's showing some kind of change over some kind of time. So let's take a look at all the information given to me. The title is telling me that this graph is going to show me the drummers in the school band. When I was in band, I always wanted to play the drums. I thought that was the coolest instrument. My mom made me play the cello instead, which I didn't think was quite as cool as the drums. So I am a little jealous of all these kids who got to play drums in the school band. I was there with my cello. So let's take a look at how many kids were playing drums in the school band. All right, how many drummers, let's take a look at our x-axis right here. This x-axis is showing us the year. So I can see this is showing me between 2006, 2007, 2008, 2009, 2010, 2011. So there's this, the time is going up 1 year at a time. And then on our y-axis, it's showing us the number of students. So this chart is showing me how the number of students playing the drums changed over time. With every year, there was a different number of students playing the drums. Let's take a look at 2006. How many students were playing the drums in 2006? Go ahead and write it on your paper. Remembering to keep ourselves so nice and organized, we can label this as just April 22nd. And I'm just wondering, in 2006, you can just make a note, in 2006, how many kids were playing the drums? Go ahead and just mark it on your paper. Excellent. 7 kids played the drums in 2006. Let's try another one. Let's try 2008. How many kids were playing the drums in 2008? Make sure you go over on your x-axis, up on your y-axis, and go ahead and write it down. How many kids were playing the drums in 2008? Excellent. There were 8 kids playing the drums in 2008. There's other information I can get from this graph as well. I could wonder, well, in which year did the most kids play the drums? What year was drumming the most popular instrument in the band? So to answer that, I would look for the year that has the highest or the most amount of drummers. See if you can solve this one and just jot it on your scrap paper. Which year had the most drummers? So on your scrap paper, you can just jot the most drummers. And then I want you to also find which year had the least drummers. All right, let's check in. the most drummers, I want to look for the highest point or the most amount. So this is my highest point up here at 9. I can follow this down to my x-axis. And in 2007, that was the year with the most drummers. Which was the year with the least drummers? Well, now I'm looking for the lowest point or the least amount. And right here, there were only 5 drummers in 2009. Not a great year for the drums. Lots of information we can get from this chart. Let's take a look at what this multiple choice question is asking. This question is asking how many drummers were in the band in 2008. Oh, easy breezy, mac and cheesy. We've already answered this one. Go ahead and find your answer for how many drummers were in the band in 2008. Exactly right. In 2008, there were, in fact, 8 drummers. And so I would select answer choice B. All right, let's take a look at a few more. At this point, you're going to be doing all of your work on your scrap paper as we pick up with question 14. So go ahead and set up your scrap paper. We'll start with question 14. I'll be keeping track of mine on my scrap paper as well, just like you'll be doing yours on your scrap paper. All right. So question 14. I'm going to start by looking at all the information given in my directions and in the chart. The graph below shows the number of teachers who retired each year over a 4-year period. Okay, so I'm already thinking to myself, this chart is going to be showing me number of teachers retiring each year. I look at the title of my graph, teacher retirements. So when a teacher has worked for so many years and they get to be a certain age and they are so exhausted from all the hard work they put in to teach you guys every single day, they get to retire. So this chart is going to show me how many teachers are retiring. Down here on my x-axis, I have the year. So this is going to be showing me change over time from 2008, 2009, 2010, 2011. And then on this y-axis, we have the number of teachers. So I can tell how many teachers are retiring each year. Before we even look at our multiple choice, let's just answer a couple questions about this chart. If I were to say, how many teachers retired in 2010? Go ahead and write it on your paper. Everyone is taking their notes along with me. Everyone should have their scrap paper completed. Go ahead and jot down how many teachers retired in 2010. And you're exactly right. It was only 1 teacher in the year 2010. Let's try one more. How many teachers retired in 2008? Excellent. 3 teachers retired in 2008. I remember this was a popular year for the drums. So maybe those teachers retired and then decided to play the drums in the school band with all their extra time. All right, a couple other things we can tell. I could ask you, which year did the most teachers retire? Go ahead and write it down. Which year? Should be done in about 10 seconds. Excellent. It is 2009. I know that because I look for the point that is the highest or that has the most, and I can see that 6 teachers, that is the most, retired in 2009. Interesting. That was the year where nobody was playing any drums. All right, lots of information I could take from this chart. Let's see what the actual question is asking. According to the graph, which statement is true? All right, so A says, a total of 12 teachers retired in the 4-year period shown on the graph. Okay, this reminds me of my spelling bee question. where it wanted to know how many kids were in the spelling bee. So we added up the amount that wore jeans, the amount that wore skirts, the amount that wore dresses, the amount that wore other, the amount that wore shorts, and we added up all of those to figure out how many total. So I could do the same process right here for choice A. I could add up the amount that retired in 2008 plus 2009 plus 2010 plus 2011. Go ahead and write your number sentence on, I'm just going to label it as this is choice A. I can see 3 teachers retired in 2008. Go ahead and finish this one up. How many teachers retired in each year? Check what you have with what I have. How many teachers are retiring in each of those years? All right, after some quick mental math, I can see that 12 teachers retired in these 4 years. Oh, which is exactly what choice A says. So that sounds great. I'm going to give that a check, but I always want to check my other choices. All right, choice B. Twice as many teachers retired in 2008 as retired in 2011. Let's check. In 2008, how many teachers retired? Go ahead and write it down. Exactly. 3 teachers retired in 2008. 2011, how many teachers retired? Go ahead and write it down. Perfect. 2 teachers retired in 2011. So now I need to ask myself, is 3 twice as many as 2? No. Twice as many as 2 would be 4. 3 is not twice as many, so this one is not correct. Let's move on to choice C. 2 teachers retired in 2010. Okay, let's take a look and go over to 2010. How many teachers retired in 2010? Go ahead and jot it down. Okay, is this choice correct? No, because only 1 teacher retired in 2010. And finally, choice D. 6 more teachers retired in 2009 than in 2008. All right, a how many more question. So let's take a look. In 2009, we had 6 teachers retire. In 2008, we had 3 teachers retire. Okay. 6 more teachers retired in 2009 than 2008. Well, I know how to solve how many more questions. I know that's just subtraction. So if 6 teachers retired in 2009 and 3 teachers retired in 2008, then the difference is just 3. 3 more teachers retired in 2009, not 6 more teachers. Only 6 teachers retired total. So let's put an X. Not correct. Which means our correct answer was, in fact, A. A total of 12 teachers retired in the 4-year period shown on the graph. Okay, let's try another one. This one I think you can try on your own. Go ahead and label on your paper question number 15. Let's take a look at all the information given in our chart. Debbie and her family took a road trip. Debbie decided to chart the miles driven from Monday to Friday. Take a look at the title of your chart to see that it's showing the miles driven. Always look at your x-axis. Okay, so it's showing the different days, Monday through Friday. And then our y-axis is showing the miles. Go ahead and answer the question on your paper of which day did Debbie and her family drive the fewest miles? Take 10 more seconds. All right, let's check in. Which day did she drive the fewest miles? Well, as I look at every single day, I see actually they're driving more and more miles each day. And so on the day she drove the fewest miles was Monday. So you can go ahead and jot down your answer to question 15. Let's try another one. All right, question 16. Again, you never know when some of these questions may repeat themselves on your independent practice. Everyone should have their notes completed. Everyone is doing the math along with me. Everyone is writing this down. Let's take a look at 16. This graph shows the relationship between the amount of rainfall and the growth of the sunflowers. Take a second to read your title, your x-axis, your y-axis, and just say to yourself, what is this chart showing? Well, this chart is showing that as the amount of rainfall increases or goes up or as the amount of rainfall goes up, the height of the sunflower grows taller. That makes sense because we know that sunflowers need water. So now let's take a look at this question. According to this data, how much does it have to rain to get a 5-inch tall sunflower? Interesting. Okay, try this one, jot down your answer, and then we'll discuss. All right. Now, one thing I might accidentally do is say, okay, well, I want a 5-inch tall sunflower, so I'm going to go to 5 on my x-axis. But then I look at my label and I realize my x-axis is showing me the amount of rainfall. It's not showing me the height of the sunflower. So in fact, if I'm looking for a 5-inch tall sunflower, I need to go to my y-axis where I have the height. I'm going to find right here, this would be a 5-inch tall sunflower. Well, am I going to get a 5-inch tall sunflower if it's only ranged 2 inches? Nope, I need to keep traveling along this point 5 until I get to where does it meet our chart. And so I can see that in order for my sunflower to grow 5 inches tall, it needs to rain 10 inches. If you didn't already have that, go ahead and fix it now. Again, you never know when some of these questions might show up on your independent practice, and now you already have the answers. So in order to solve this, I had to find that point where a 5-inch tall sunflower meets the amount of rain. How much did it have to rain? Well, it has to rain 10 inches in order for my sunflower to grow up to be 5 inches tall. All right, couple more. All right, question 18. Go ahead and read this information on your own. Go ahead and answer this one on your own, and then we'll check it. So you're noticing the title, you're noticing what is being shown on the x-axis, you're noticing what is being shown on the y-axis. right, let's check in. I see that this is graphing test scores. I have my students, Joe, Bill, and Peter down here on my x-axis and their test score on the y-axis. I can see each student's individual scores. I can see how much higher each student scored than another student. Let's take a look at what the graph or what the question is asking. According to the graph, which statement is true? Okay, let's read choice A. All 3 students earned scores of 80 or more. Go ahead and evaluate that with your thumbs. Is that a true statement? Yes or no? No. Look at Joe. Poor Joe only scored 75, not an 80. So they did not, all 3 of them, score 80 or more. We can X this one out. Let's look at choice B. Peter had the highest score of the 3 students. Go ahead and evaluate with your thumbs, thumbs up or thumbs down. Did Peter have the highest score? No, he didn't have the highest score. Bill had the highest score. Here's Peter's score right here at 85, not as high as Bill's score, so not correct. Let's take a look at choice C. Peter's score was 10 points higher than Joe's score. Okay, let's look at Peter's score. I'm going to go over on my x-axis up to Peter's score. Now it's in between the 80 and the 90. I know that that's 85, right? So we go 80, 85, 90. So Peter scored an 85. Let's take a look at Joe's score. Joe, I'm going to go over on my x-axis to Joe, up to where Joe scored, and Joe scored a 75. So if Peter scored an 85 and Joe scored a 75, that is 10 points higher. So C could be a correct choice. Let's take a look at D. Bill scored 95 points. Let's find Bill on our x-axis. Let's go up. Now, Bill did well. He got a 90, but he did not score 95. So my correct answer would be C. Peter's score was 10 points higher than Joe's score. All right. That's the last one we're going to take a look at together. Just to give you a preview of what you'll be working on your own. You're going to be looking at some soccer games that were won. Make sure you're reading the questions carefully. So you know, is it asking how many somebody did, how many more, who had the most, who had the least. Always reading the title of the graph, reading your x-axis, reading your y-axis. So you're going to have a couple to try on your own. All right, scholars, best of luck. You should have lots of correct answers to some of the questions that are on your quiz or on your independent practice today. So excited to see some great scores. You should have some great tools to interpret these graphs and charts today, remembering that you always want to take a look at the titles, take a look at your axes, so you know what the graph is showing. All right, best of luck. Cannot wait to see how well you do.